A leading firm requires software for its internal use. The firm wants to evaluate whether it is less costly to have its own programming staff and resources or to have programs developed by an external development firm. The cost of both options are a function of the number of lines of code. After the mathematical analysis, it has been estimated that the in-house development will cost $1.75 per line of code, and in addition, annual overhead costs for supporting the program will be $35,000, while software development outside the firm costs an average $2.50 per line of code. How many line of codes per year make cost of the two options equal? If programming needs are estimated at 35,000 lines per year, what are the costs of the two options? And then in part B, what would be the in-house cost per line of code to have equal for the two options to be equally costly? So let's do A. So the in-house is equal to the in-house function is equal to the cost per line of code, which is 1.75, and then we multiply that with the number of lines of code, and then plus the annual cost, the overhead cost, which is $35,000. So the function is 1.75 times n plus $35,000. Now the outside is equal to the 2.5 times the number lines of code. So they asked for the cost of the two options to be equal. So we set them equal to each other. So we have in-house equals the outside. So 1.75 n plus 35,000 is equal to 2.5 times n. So we solve for n. So this is equal to, so 2.5 minus 1.5, 1.75 is equal to 0.75 n. So n is equal to 35,000 over 0.75, or n is equal to 46,666.67. So this is A. Now B, if programming needs are estimated at 35,000 lines per year, what are the costs of the two functions? So we plug in n is equal to 35,000. So n is equal to 35,000. So we use the function. So 1.75 times 35,000 plus 35,000. So this is in-house. So this is equal to, so 35,000 times 1.75 plus 35,000. So this is equal to 96,250. Now the outside is equal to 2.5 times 35,000. So this is equal to 87,500. So that's B. In part B, what would be the in-house cost per line of code have to equal for the two options to be equally costly? So C. So let x is equal to the cost per line So we have 35,000 x plus 35,000 is equal to 2.5 times 35,000. So we have 35,000 x plus 35,000 equals 87,500. 87,500, yes. So we subtract 35,000. So we have 35,000 x is equal to 87,500 minus 35,000 is 52,500. Then we divide 35,000. So x is equal to 1.50. So there's a part B in this problem. Because the parameters used in mathematical models are frequently estimates, actual results may differ from those projected by the aforementioned mathematical analysis. To account for some of the uncertainties which may exist in a problem, an analysis often conduct sensitivity analysis. The objective is to assess how much a solution might change if there are changes in the model parameters. Assume in part A that the software development cost by the outside firms might actually fluctuate by plus and minus 15%. Compute the break-even points if the costs are 15% higher or lower, and compare your results with the mathematical model achieved prior to the sensitivity analysis. So let's do part B. So part B. So the in-house is the same because it doesn't change. So in-house is equal to $1.75 times the number of lines per code line. So and then plus 35,000. Now the outside firm might fluctuate by plus and minus 15%. So this is 2.5 times 1.15 n, because we add 2.5 plus 15%, so this is equal to 1.75 n plus 35,000 is equal to 2.875 n. Then we solve for n. So we subtract minus 1.75 n minus 1.75 n. So we have 35,000 equals 2.875 minus 1.75. So this is 1.125 n. Then we divide 1.125. So n is equal to 1.125. So 31,111.11. So this is plus 15%. Now it is if it is minus 15%, so minus 15%. So the in-house is the same. So 1.75 n plus 35,000 equals 2.5 times 0.85 n. So this is equal to 1.75 n plus 35,000 equals 2.5 times 0.85. So this is 2.125 n. So minus 1.75 minus 1.75 n. So 35,000 equals, so minus 1.75, so 0.375 n. So n is equal to 93,333.33. So this is minus 15%.